Alright, in this video we are looking to find the average value of a function. So what that means is we are looking to find the average height of one rectangle that will give us the exact area under the curve. So suppose we have this function here that is sketched for us, and we're interested in finding the exact area under the curve. Well, if it's bounded between A and B, we know that this region here that I'm shading in green represents our exact area. Okay? So what we're looking to accomplish here is we're trying to draw in a rectangle. Now just one, alright, one rectangle that will give us the exact same area as what I just shaded. Well, the width of the rectangle is going to be b minus a. Alright, it's the same width we see here. And it's a matter of finding the average height that we need so that those areas would match up. Well, in this particular example, the average height that we would need for our rectangle would be approximately right here. So if you have different colors, please use them. So if you were to look at this rectangle in its area, notice how we have, let me grab a different color here, this region here kind of cancels out that region there. Okay? And so as a result, the area of my purple region here, which is really the area of a single rectangle, that would equal the area under the curve. Okay? Now we call this height here f of c. All right, that is the height of our rectangle. All right, from there to there, we're going to call that f of c. Okay, and then that means that this x value is just c. So c is what we call the x value, all right, where it takes on a height of f of c. So what this means is if we look at the area of the rectangle, we know that f of c times b minus a, right, that's the dimensions of the rectangle, right? So we have the width of b minus a times the height of f of c. That is going to equal the exact area, which we know can be represented as a definite integral. Okay, so from here, if we were to solve for f of c would equal, well, I could divide over that b minus a, which is the same as multiplying by 1 over b minus a, and then times the integral from a to b of f of x dx. Okay? This right here is our formula for finding average value. So just a couple things to keep in mind. Just some notation here. By average value, we mean f of c in our formula. Okay? It equals the height of a rectangle. Okay? So sometimes you'll see f of c for the notation, but other times you'll see lowercase f and then sub AVE for average. Okay? Usually we see f and then the AVE for our notation. Okay? So you just simply need to know that this is the formula for finding the average value of a function. So where does this whole notion of average come in? Well, it's an average height of just a single rectangle that would give us that exact area under the curve. Okay? So let's look at some examples. Alright, check out this example. So we're given this graph here of f of x, and we're asked to find the average value on this function. So we have some key points here. Alright, negative 2 to 6 are the x values that it spans from, and then the highest point it's going to reach is 5. And it looks like the y-intercept is 3. So let's start by finding the exact area underneath this curve between negative 2 and 6. So we're talking about a definite integral from negative 2 to 6, and then we have f of x dx. Well, it's a triangle, and we know that the area of a triangle is simply 1/2. The base would be 8, right? The distance between negative 2 and 6 would be 8. The height would be 5. That is going to give me 20. So 20 is my exact area. All right, that's the area underneath that curve. So what we're trying to find is the average value. Now recall that we said average value is equal to 1 over b minus a times the integral from a to b of f of x dx. Well, we're trying to find the average value, and we know that the exact area is 20. So we have this piece that we're trying to find. We can do our 1 over b minus a. All right, we know that it's going to be 1 over 8, okay, because this is really our a and this is really our b. And then we found that the exact area, or the definite integral, is 20. So our average value here is really 20 divided by 8, which is 2.5. Now, recall that this is really the rectangle height. So let's attempt to sketch this and draw it in here. So we know the width is 8, all right, it spans between -2 and 6, and the height is 2.5. So let's say 2.5 is up there. So I'm drawing in my rectangle. So the idea is the area under the curve is equal to the area of the rectangle. This outer region plus that outer region would cancel out this region right there. Okay, so the rectangle area equals the area under the curve. That's what the average value of a function is really telling us. Alright, last example. So we want to find the average value again of this function, 4 minus x squared. Our interval here is from 0 to 3. Again, those are x values. This is really the a, this is really the b. And we also want to find its corresponding x value. So let's start by writing down our formula for average value of a function. Remember, you're going to have to commit this to memory. It's not going to be given to you. So our average value here, so we're going to have 1 minus the 3 minus 0 times, then we're going to take those and turn them into our bounds on this definite integral. So let's throw in our function here of 4 minus x squared. And for now, we are just going to use fn int in our calculator to evaluate that. So just a little note, use fn int for now. So if we do that in the calculator, you're going to get a nice clean answer of 3, which means when we multiply that to the 1/3, we're going to get 1. So 1 is the average value that we would have for the height of our rectangle. So let's sketch this function and use that to help us figure out how we're going to find the corresponding x value. Alright, so here's our function 4 minus x squared drawn between 0 and 3. Notice how we have a region above the x-axis, and then we also have this region below. So let's just pause for a moment and write a couple expressions to represent these regions. This top region can be represented as the definite integral from 0 to 2 of 4 minus x squared dx. If you threw that into your calculator, you would get 5.3 repeating. This bottom region here is really the definite integral from 2 to 3 of, our function 4 minus x squared dx. If we threw that into the calculator, we're expecting it to be negative since that region is below. And lo and behold, it will be. And notice how that if you were to combine these two, all right, we talked about how, well, I won't write it again. I'll just draw your attention up to this part. We said how the total area there from 0 to 3, so if we were to combine these two, the 0 to 2 plus the 2 to 3 would give us the total distance starting from 0 and stretching all the way to 3. Notice how if we combine those, the 5.33 minus the 2.33 would give us exactly 3, which is what we said right here. Okay, so we already know that. So the average value we just found to be 1. So remember, this represents the rectangle height. So we know the rectangle width needs to be 3. The rectangle height would have to be 1, because notice that 3 times 1, all right, the dimensions here of this rectangle, 3 times 1, 3 by 1, would give us the same area of 3. Okay, so this is the y value on our rectangle. If the width is 3, that would give us the same exact area that we need. Okay, we know the area of this definite integral is 3. Okay, so that's average value of a function. But now its corresponding x value. So to find that, what we're going to do is we're going to take the average value and we're just going to set it equal to the function. So we're going to set that equal to 4 minus x squared. Okay, so we're going to set the average value equal to f of x. So the average value is 1, and then the function is 4 minus x squared. See what we're trying to find here on our graph? If I go back to this for a moment, right here, this is the point where the rectangle crosses the curve. So we are trying to find the x value that goes with that. Okay, we can see it's somewhere between 1 and 2. So when we're trying to find the corresponding x value, we know that the height is 1. We're going to just simply solve this equation. All right, for x, try to figure out where it's going to be the same. So this is going to give us negative 3 equals negative x squared, or 3 equals x squared. Well, x would technically be plus or minus the square root of 3, but this negative we are going to reject since it's outside our interval from 0 to 3. Okay, so the only x value here that we care about is the square root of 3, all right, which is about 1.7. Okay, so that looks pretty accurate on our graph. So x equals radical 3 would be the x value where the rectangle is hitting the function. Okay. Oh, and one more thing. Sometimes the average value of a function is known as, so aka, the mean value theorem for definite integrals. Okay, so we know average really is the same as a mean. Okay, so that should make sense to you. So sometimes the average value of a function is referred to as the mean value theorem for definite integrals. Recall we had a mean value theorem for derivatives that dealt with the slope of a tangent line being equal to the slope of a secant line, all right, on a continuous and differentiable function. But here, this is referring to a definite integral, so the mean value theorem is also known as average value. Okay, but 99% of the time it's just referred to as average value of a function. Okay, I'll finally shut up. Bye-bye.